Welcome to the beginning of Algebra 2 Regents, or as some like to call it, Common Core. Okay, finals review. All right, we are going to start with the June 2016 exam, in case you didn't see that. This was the exam that students took in June of 2016, similar to an exam that you will sit down and take. These videos will roughly be about 8 questions per video. All right. And I figure that's about a half an hour's time, sometimes a little bit less, sometimes a little bit more. And you'll also notice that I have this little legend here. This is just for what I do for my class, okay? I try and figure out how many problems deal with algebra, data or stats, trig or exponentials, or just general miscellaneous. And they are color-coded. So as I move forward to problem 1, you'll see that this is highlighted in orange. So that's something that I would have categorized as pretty much an algebra problem. All right? So without wasting any more time, let's move forward and do some math, okay? First thing, I would just like to read the directions for part 1. Answer all 24 questions in this part. Each correct answer will receive 2 credits. There is no partial credit allowed. A lot of students will ask me, oh man, I need to do good on multiple choice. No, I mean, you do, but in order to score really, really well, yes, you need to do good on multiple choice, but you also need to get some credit on short answer. There is no partial credit in multiple choice. Even if you get it partially right, it's either right or wrong, okay? Of course, you have the use of a calculator for every single question on this test. You have it for the entire time, and sometimes it comes in handy, all right? So let's take a look at number 1. When b is greater than 0 and d is a positive integer, the expression 3b all raised to the 2d is equivalent to what? This is just a question testing you on your knowledge of exponents, more specifically, rational exponents. In my class, I say top down, bottom out. So if I have 3b raised to the 2d, the top number just slides down. So I have 3b squared. And the bottom, out. That becomes my root. Top down, bottom out. That's the answer. And that, as I'm looking at this, is choice 4. D is the root, and this just slides down and we square it. Okay? Pretty simple. It's a nice, easy one to start with. Number 2. Julie averaged 85 on the first 3 tests of the semester in her mathematics class. If she scores a 93 on each of the remaining tests, her average will be 90. Which equation could be used to determine how many tests T are left in the semester? I really don't like this question because it just tests you on finding the average of something, which is a topic we don't really dwell on in Algebra 2. I guess it tests you on your number sense, basically. Okay, so this is what I know. On the first 3 tests, this girl Julie scored an 85. So I have 3 tests. I'm just going to write this to the side. They're 85 each test, all right? Now, she scored a 93 on the remaining tests. So she got a 93, we'll just say T tests. We don't know what that is, okay? So her average would be 90, okay? 93 on each of the remaining tests. We don't know this. This is T. We don't know the remaining tests. So obviously, if I figure out an average, it should equal 90. Okay, so I'm looking at this, and I'm looking at these equations, and I don't want to equal the 93, so gone, gone. It's either 1 or 3. Now, how do we figure out an average? We add everything, so we sum everything up, and then we divide by our number of tests, right? By the number of tests we have. Okay, we add all of our tests up and do that. So, okay, well, I can add my 3 85s. 85 plus 85 plus another 85. So if I do 85 times 3, I actually get 255. So on my top here, I'm going to take 255, and I'm going to add it. Now here's where the conundrum is. I don't know how many tests she scored a 93 on. All right? I know for a fact that if there was one test, it'd be 93 points I would add to this 255. If it were two tests, it would be 186. It'd be 93 plus 93. Or I can look at that as 93 times 2. If we're three tests, I do 93 times 3. So whatever I add to 255, I take 93 and I add that t times, right? So I'm just going to times t. So my top right now should be 255 plus 93t. Okay, that's right here. That's good. That's also right here. So really, the one difference that's going to help me is what my denominator is. I divide by the number of tests. I have 3 tests. I should do this in a different color. 3 tests that are 83 or 85 and t tests that are 93. If I add those two together, 3 plus t, that's just an expression, 3 plus t. Bam. Answer is choice 3. Number 3. Given I is an imaginary unit, 2 minus yi squared in simplest form is. I am just going to FOIL this out. It tests you on your knowledge of imaginary numbers when you multiply them together, as well as just practicing FOILing. All right. So 2 minus yi squared is like saying 2 minus yi times 2 minus yi. So I am just literally going to FOIL this. 2 times 2 is 4. Okay. 2 times a negative yi is negative 2 yi's. We have the same thing here. 2 times negative yi, so negative 2 yi's. And last but not least, negative times a negative will give me a positive. If I have yi times yi, I would have y squared I squared. All right? Trust me, that's what you get. Now, the only thing I can combine here are these two bad boys. So right now, I'm going to continue this right here. I have 4 minus 4 yi's. Now, here at this point, everything has been somewhat simple. Here's the test. You need to remember that I squared is the same thing as negative 1. That's really what this question is testing you on. So if I have y times I squared, excuse me, if I have y squared times I squared, but I squared is really negative 1, that's going to give me negative y squared. There you go. Now, I look at my answers, and I really don't see anything written like that. They wrote it in standard form, meaning they put the biggest term first, negative y squared. They put y to the first power next, minus 4 yi's. And then last but not least, my positive 4. This is the same thing as what I have right here. And that, my friends, is choice 2. The big thing to remember, again, I squared is negative 1. Number 4. Okay, number 4. I'm going to move this over here to get it out of the way. Which graph has the following characteristics? All right. It has 3 real zeros. As x approaches negative infinity, f of x, which is really the same thing as y, approaches negative infinity. And as x approaches positive infinity, f of x, or y, also approaches positive infinity. So let's take a look at 3 real zeros. So I'm going to highlight. Let's look at this first. Let's see if we can eliminate. All right. Well, 3 zeros. This touches 0 is where it touches the x-axis. 1, 2, 3. Okay, that's good. 1, 2, 3. Okay, that's good. Touches here. 1, 2, 3. That's good. touches here. 1, 2, 3. Okay, so having 3 real zeros doesn't help us at all. Okay, we did that. They all have 3 real zeros. So now we got to check the following. As x goes to negative infinity, y goes to negative infinity. Now, in case you forgot, and I'm going to use the graph for one here, x is my horizontal line. Negative infinity is all the way to the far left. And if I go positive infinity on the x, that's going to the right forever. Okay. Now let's look at my y-axis. That's the up and down axis. As y goes up forever, it is heading toward positive infinity. If y goes down forever, that would be heading toward negative infinity, okay? So when they ask me this right here, I'm going to look at this one. As x goes to negative infinity, which means as it goes this way forever, y is going to go also to negative infinity, which means it will go this way forever. So that means it's going to go down and to the left, okay? I should be going down and to the left based on this piece of information. Does graph 1 go down to the left? No, it goes up and to the left, so it can't be 1. 3, well, 3 goes down and to the left, so the further I go this way, the further left it's going, and the further I go this way, the further down it's going. That's good. So 3 is a possibility. Okay, let's take a look at number, what is that? 2? 2, well, this goes up and to the left. That's not good. Number 4 definitely goes down and to the left. So we got 2 possibilities right now, either 3 or 4. So let's take a look at our last piece of information. As x goes to positive infinity, y also goes to positive infinity. So 3, as x goes to positive infinity, y also goes to positive infinity. So as I go to the right more, I go up more. And that's exactly what number 3 does. If I look at number 4, as I go to the right more, I'm not going up, I'm going down to negative infinity. So it can't be 4. They're just testing you on your ability to know notation and to read a graph, the end behavior of the graph. Number 5, I love these problems. I love when they're just straight up algebra. And that's why it's highlighted in orange, because it's just a straight up algebraic problem. Okay, the solution set for the equation radical 56 minus x equals x is. All right, I'm going to do this algebraically. There are 3 ways I can think of to do this. There might be more. One is algebraically, we're going to do the math. Why am I going to show you that way? Because if this was a part 2 question that was not multiple choice, you would have to know how to do it algebraically. Okay, I can do this graphically. I can also do the plug and chug method by plugging in numbers and see if they work. All right, easy. Let's do this algebraically. If I have radical 56 minus x equals x, the first thing I'm going to do is get rid of that radical. They're nasty. So square root and square are opposite math. They cancel. What I do to one side, I have to do to the other. 56 minus x equals x squared. That screams, it reeks of quadratic. So I know to solve a quadratic, I get everything to one side, set it equal to 0, booty cheek and T-bone, which means I factor and solve. I like when my x squared is positive, so I'm not just going to subtract x squared from both sides. I'm going to bring my 56 and negative x from the left to the right. So I add x, I add x, I subtract 56, I subtract 56. I now have 0 equals x squared plus x minus 56. You cannot ever forget how to factor. Ever. 2 numbers that multiply to negative 56 that add to positive 1. X plus 8, x minus 7. Positive 8 and minus 7, and negative 7, they multiply to negative 56. They also add to 1. I'm good to go. There's my booty cheek, and now I T-bone. X equals negative 8. X equals positive 7. Now, I look and I say, oh, hey, look, that's number 1. But when it comes to square roots, okay, you need to check both your answers. Because remember, every once in a while we can get an extraneous solution. That means we get a number that seems to work out algebraically, but when we check it, it doesn't work. Okay, if I check 7, 56 minus 7 is 49. Oh, I'll do it here. 56 minus x, which is 7, equals x, which is 7. Square root of 49 equals 7. 7 equals 7. Boom. This is an answer. Okay, so 7 has to be an answer. It's not negative 7. It's not nothing. But look what happens when I try 8. When you get an extraneous solution, which is what we're going to get with negative 8, it always tries to work out, but quite doesn't. So if I have radical 56 minus 8, well, excuse me, minus x, which is negative 8, equals x, which is negative 8. First off, I know I will never get a negative value from a square root. I know right there that it's not going to work. Okay? Well, let's just finish this off. When I subtract a negative, it's like adding. Okay? 56 plus 8 is 64 equals negative 8. 8 does not equal negative 8. You see how it kind of tries to work, but it just kind of doesn't. So this is an extraneous solution. This one does not work. So those of you that would have circled 1 right off the bat would have been wrong. And because this is multiple choice, you get no partial credit. Put that in your pipe and smoke it. Now, I don't like to sit here and do every single method to solve every single problem. But since this is the first one, let's do this. First off, okay, I'm going to erase some things here. I could have, actually, let me know. I could have just tried this. I could have plugged in, these are answers, okay? X is negative 8 and X is 7. I could have tried them. That's really what I did when I checked. Here's trying to put in negative 8. If I know by plugging in negative 8 it doesn't work, I know 1 can't be an answer. If I plug in a 7 for X, okay, and I see that it works, I know my solution should have a positive 7 in it. This is the only one that has a positive 7 that does not have a negative 8. Okay, so I can take my answers, plug them into my X's, and see if it works. Okay? Or whenever I have two equations that are set equal to each other, and I'm only using one variable, in this case it's X, okay? I can put this into Y1, I can put this into Y2, I can graph them and I can see where they intersect. The X coordinate of where they intersect is going to be my answer. It should be 7, right? We just did this. Let's try this out. Open this up. In fact, I don't really do this because on YouTube you have that monster screen, but I'll do this right here. So I'm going to go to y equals. Let me move this bad boy out of the way. And I'm going to put in y1 the square root. Oh, let's clear that out. We don't want that. The square root of 56 minus x. And in y2, I'm just going to put x. Now, I'm going to make sure I have a standard 6x6 window. I'm going to graph this here. There is the square root of 56. There is x. Okay? If I check the intersection point right here, that's the point of intersection. It only crosses once. This will keep on going down, down like that. Okay, and this will just kind of continue to go straight up, so they won't intersect again. Okay, so if I want to figure out that intersection point right here, all right, I've got to go to second and then trace, because above trace in blue it says calc. So I want to go to second, trace, and I want to pick intersection, which is 5. And I bring my little bug dude here close to the point of intersection. So I'm just going to hold this. And I'm just going to hit enter 3 times. Bang, bang, a biggity bang, bang. When x is 7, y is 7. That happens to be coincidental. I'm trying to solve for what? The x, right? So I want to look for the x. My x is 7. There's only one point of intersection. So there's only one answer. Bam. So my answer is x equals 7 right there. Okay, don't don't just discard the calculator. It is your friend. Number 6, okay, zeros. Okay, I could graph this. All right, if I graph this in the calculator, my zeros are the same thing as y-intercepts. Okay, I can use this. Okay, I can graph this equation, and I can use go to second calc, and instead of pick intersect or intersection like I did on problem 5, I can pick zeros, and I can figure out the 3 zeros or 4 zeros, and that would be my answer. Okay, but let's do this algebraically just in case. Okay, just in case you have to do this algebraically on the test. If I want to find the zeros, those are the same thing as y-intercepts. They're the same thing as the solutions. I'm just going to solve for x. Going to factor and t-bone. Booty chicken t-bone. The first thing I notice is every single term has an x. I'm going to factor that out, which means I'd have x cubed left minus 4x squared minus 9x plus 36. I lost an x from every term because I factored it out. Now what's left is classic factor by grouping. There always seems to be one problem where it's factor by grouping, and kids tend to forget factor by grouping. Don't forget it. I take the first 2 terms, and I take the second 2 terms, and I factor something out. And what's left in my red parenthesis and blue parenthesis, I want to match. Okay? So let's do this. This x just comes along for the ride. So let's do this. I can take out an x squared. What's left will be x minus 4. Okay? And in my blue parenthesis, I can take out a, well, I want it to match. So I'm going to take out, not, if I took out a 9, that would leave me negative x plus 4. That does not match here, does it? So I'm going to take out a negative 9 and flip these signs, and then it's going to match. So negative 9, I get x minus 4. Okay? Now these 2 things in parentheses here, in the red and blue, they match. All right? So let's take a step further. Just come along for the ride. This and this go in its own parenthesis. And these 2 get put together in one parenthesis as well. That is factor by grouping. But, my friends, I can still factor this. That is a difference of perfect squares. So my x, that just comes along for the ride. This is x plus 3 times x minus 3. Okay, this came from x squared minus 9, factoring one more time. And I still have my x minus 4. Now it's just a point where I t-bone, set all these equal to 0 and solve. Well, x equals 0, solved. Okay, x, I flip the sign, minus 3. I flip the sign, a positive 3 and a positive 4. So which answer has 0, negative 3, positive 3, and 4? It looks like to me that is choice 1. 0, plus and minus 3, positive and negative 3, and 4. That is your answer. Now, I said you could solve this graphically, and I'm not going to do it in the calculator. But if I were to graph this, here's 4, here's 0, here's 3, here's negative 3. Those are all our answers, right? If I graph this, it would look like this. Da, 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 da. It would look like that. And it would cross the x-axis at negative 3, 0, positive 3, and positive 4. So that's how I know, graphically, what the answers would have been. Question about data and stats. Number 7. Anne has a coin. She does not know if it is a fair coin. She flipped the coin 100 times, and she obtained 73 heads and 27 tails. Okay? She ran a computer simulation 200 times. And each of those 200 times, a coin was flipped 100 times, a fair coin. The output of the proportion of heads is shown below. The mean is 0.497. So I'm going to go here. This is the average right about here, 0.497. Which is about right because flipping a coin is 50-50. That's really close to 50%. All right. The standard deviation is 0.05. So they rounded this to 0.50. If you add one standard deviation here, this is one standard deviation. You go here, that's a second standard deviation, okay? Same thing, 1, 2 standard deviation. This actually goes out a third standard deviation. If I go out a third standard deviation here, 0.65, there were no outcomes. Each one of these dots, there are 100 dots here. Each dot represents one of the outcomes, okay? So let's take a look at what our choices are here. Yeah, that's the right word. Given these results, all right, of her coin flips and her computer simulation, which statement is the most accurate? 73 of the computer's next 100 coin flips will be heads. So it's saying, well, the next time the computer does it, will it come out? No, that's, I mean, 0.73 is way out here. It's not even on the spectrum of the possibilities. No way. That's not the most accurate. 50 of her next 100 coin flips will be heads. I mean, maybe, because it's always 50. That seems to be the one that came up the most. But let's see if that's more accurate than the rest. Okay, her coin is fair. I'm going to go right to number 4. Her coin is not fair because she actually got this. That is not on the spectrum of possibilities. No way. Her coin is not fair. So here's what we got to do. It's between 2 and 3. So would I say that the next computer simulation will be 50? Or is her coin not fair? Look at all, okay, these are all the possibilities of 0.50. Look at all the other possibilities that it can come out to be. You see this? There are a lot more possibilities of not being 0.50 than being 50, okay, than being a 50-50 split. So I'm going to say no to this one. No way. I think this one is most accurate. This girl doesn't have a fair coin because out of 100 times, not once did it come out this way. That's not a fair coin at all. And I would lean toward number 3 anyways, because here's the question. She doesn't know if her coin is fair or not. Number 3. Now let me explain number 2 one more time. If I look at how many dots are here out of my 100, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 out of the 100 came out to be 50%. That's only 24% odds. I mean, so there's no way that's, I mean, yes, there's a 24% chance, but it is 0% chance on the simulation that you get 0.73. So her coin is definitely not fair. All right, number 8, and then we're going to stop here. Okay, they give us g of c, that's 1 minus c squared. They give us m of c, which is c plus 1, and they ask us which statement is not true. If I FOIL these two together, that's what this means, multiplication, I will indeed get this. All right? If I, all right, add those two together, if I add those two together, I will indeed get 2 plus c minus c squared. If I subtract these two, I will get c plus c squared. How else can I do this? I can put these in the calculator. I can put in y1 this times this, literally just put 1 minus c squared times c plus 1. And then I can put this into y2, and you will get the same exact graph. The only one that if I put in the calculator that I don't get the same graph is choice 4. Okay? Now let me show you that algebraically, because I think that would be better. But you could put these in the graph. You could put these in the calculator, right? I could take m of c, which is c plus 1. I could subtract g of c, which is 1 minus c squared. I could put this into y1. And in y2, I could put c plus c squared, and the graphs will be exactly the same because they're equal. Number 4 is the only one that won't turn out that way. So let me show you algebraically number 4. I'm going to take mc, which is c plus 1, over gc, which is 1 minus c squared, and see if it ends up this. I'm going to factor the bottom here. C plus 1, that is a difference of perfect squares. 1 plus c times 1 minus c. The great thing about that is these now cancel. C plus 1 and 1 plus C are the same. So I get 1 over 1 minus C. Does that equal negative 1 over 1 minus C? It does not. This one's negative. This one's positive. Those are not equal. That is the only one that is not equal. Thanks for hanging out with me today. That's problem 1 through 8. The next video will be problem, I don't know, 9 through 17. See you then.